Hi everyone, welcome to our class. Today I am going to discuss the derivative of a function. And at the end of this video, you should be able to understand the geometric definition of the derivative of a function. Find the derivative of a polynomial function, find the derivative of a rational function, and to find the derivative of a radical function using the delta method. I am now going to discuss the geometric definition of the derivative of a function. So let us solve the problem. Find the derivative of the function y is equal to f of x at point 1 having the coordinates x, y. Okay, I am going to enumerate the solutions on finding for the derivative of the functions. Our first step is to consider portion of the graph of the function y is equal to f of x and the given point p sub 1 having the coordinates x, y. So that means point 1 has a horizontal distance from the y-axis equal to x and its vertical distance from the x-axis equal to y. The next step is we are going to consider another point, say point 2, on the graph of the function having a horizontal distance delta x from point 1 and the vertical distance delta y from point 1. So from the figure, you will see that the horizontal distance of point 2 from the y-axis will now be x plus delta x, and its vertical distance from the x-axis is y plus delta y. So point 2 now has coordinates x plus delta x and y plus delta y. Now if we are going to connect the 2 points with a straight line, this line is what we call a secant line. And if you still remember, the ratio delta y over delta x represents the slope of the secant line. Okay, so the next step is let delta x approaches 0. So notice what will happen when you say delta x approaches to 0. That means the horizontal distance from point 1 to point 2 will now be almost equal to 0. So what will happen then is that as delta x approaches to 0, point 2 approaches point 1. And that the line joining point 1 and point 2 will now approach a tangent line at point 1. And so therefore, the ratio delta y over delta x, which is the slope of the secant line, if delta x approaches to 0, the ratio delta y over delta x will also approach the slope of the tangent line. Now, if you still remember in our discussions on limits, the statement if as x approaches to a and f of x approaches L, then we consider L as the limit of this function as x approaches to a, which in symbol is written as the limit of f of x as x approaches to a is equal to L. So you look at this statement, as delta x approaches to 0, delta y over delta x approaches the slope of the tangent line, and we have in here, as x approaches to a, f of x approaches to L, these two statements are similarly constructed. That means we can write also this statement as the limit of the delta y over delta x as delta x approaches to 0 is equal to the slope of the tangent line. So we have already established that the limit of delta y over delta x as delta x approaches 0 is equal to the slope of the tangent line. Remember also that the slope of the function is equal to the slope of the tangent line at the point of tangency. So if we go back to the graph of the function y is equal to f of x and point 1 on having the coordinates x, y, the slope of this function at point 1 is equal to the slope of this tangent line. Or the slope of this function at another point, say point 2 in here, the slope of this function is equal to the slope of this tangent line. And so therefore, we say that the limit of delta y over delta x as delta x approaches to 0 is equal to the slope of the function. Now, other symbols which are used to denote the limit of delta y over delta x as delta x approaches to 0 is we have the derivative of y with respect to x written as dy over dx, or we have the derivative of y with respect to x. Note in this symbol that d over dx represents an operation we are going to apply to the given function y. That means we're going to find the derivative of y with respect to x, giving us an idea that y is the dependent variable and x is the independent variable. Or we write this one as y prime. Again, we read this as the derivative of y with respect to x. So we therefore have the definition now of the slope of the function. The derivative of y with respect to x is equal to the slope of the function. Let us now discuss the general steps in finding the derivative of the function, or we call it the delta method of finding the derivative. So given the function y is equal to f of x, find the derivative of y with respect to x. Our first step is to substitute x by x plus delta x and y by y plus delta y. That means in this function, if there is a change of x by an amount delta x, so there will be a corresponding change of y by an amount delta y. Hence, the function now becomes y plus delta y is equal to f of x plus delta x. The next step is to solve for delta y. So in this equation, we simply transpose y to the right. So we have delta y is equal to f of x plus delta x minus y, whose value is equal to f of x. Now, before you proceed to the next step, you have to manipulate this function so that you will be able to obtain a factor delta x at the right side. By then, you are now ready to divide the equation by delta x, and so you have delta y over delta x is equal to f of x plus delta x minus f of x all over delta x. Then the next step is to evaluate the limit of the function as delta x approaches 0. So we evaluate the limit of the left side as delta x approaches to 0. You do the same at the right side. Evaluate also the limit of the right side as delta x approaches 0. So we know that this limit of delta y over delta x approaches to 0, may be written in symbol as dy over dx. So we now have in here the derivative of the function y with respect to x, and that is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. Let us now solve the problem. Find the derivative of the function y is equal to x squared minus 2x plus 3. What is the slope of the function at 1, 2? So we start our solution by following the steps. We have substitute x by x plus delta x and y by y plus delta y. So in this function, each x will be substituted by x plus delta x. That will give us now y plus delta y is equal to x plus delta x quantity squared minus 2 times x plus delta x plus 3. Then the next step is to solve for delta y. Transposing y to the right side, we have now the delta y is equal to the square of x plus delta x minus 2 times x plus delta x plus 3 minus y. So simplifying the equation algebraically, we have delta y is equal to, this one now is the square of binomial that will give us x squared plus 2 times delta x plus the square of delta x. To take note of this bar, this is placed to let you know that delta x is just one variable. So we have the square of delta x minus, applying distributive property, minus 2x minus 2 delta x plus 3 minus y, whose value is x squared minus 2x plus 3. So simplifying this one further, we could collect similar terms. Notice that x squared and the minus x squared cancels out. The minus 2x and the minus negative 2x cancels out in here. Plus 3 and minus plus 3 cancels out. And so what is left? We have the delta y is equal to 2x delta x plus delta x squared minus 2 delta x. So notice that in this equation, each term at the right side now contains delta x as a factor. So we are now ready to divide the equation by delta x, and that will give us now delta y over delta x is equal to 2x plus delta x minus 2. As you will notice at the right side, each delta x in here cancels out with this delta x. Okay, so we are now ready to proceed to the next step, which is to evaluate the limit of the function as delta x approaches 0. So we have now the limit of the delta y over delta x as delta x approaches to 0. We do the same on the right side. Evaluate also the limit of 2x plus delta x minus 2 as delta x approaches 0. So that's simplifying now, or evaluating now the limit at the right side. We substitute delta x equals 0, so that will now be 2x plus 0 minus 2. And we know in symbol that limit of delta y over delta x as delta x approaches to 0 is the derivative of y with respect to x, that is now equal to 2x minus 2. This function now represents the equation of the slope of the graph of this function at any point, so that the slope of the function at 1, 2 will now be equal to, slope is represented by m. M is equal to the derivative of y with respect to x, which is equal to 2 times x is equal to 1 minus 2. So from this point, x is 1. So we substitute. That means the slope of the function at 1, 2 is equal to 0. This value of slope at 0.12, which is equal to 0, will give us an idea that the tangent line or the line tangent to this function at 1, 2 is a horizontal line. Let us now solve another example. Find the derivative of the function y is equal to 2x plus 5 all over 3x minus 1. So for our solutions, we follow the same step. First is to substitute x by x plus delta x and y by y plus delta y. Giving us now y plus delta y is equal to 2 times. We substitute this x by x plus delta x plus 5. And so with the denominator, that will be 3 times x plus delta x minus 1. The next step is to solve for delta y. So we can just transpose y to the right side of the equation, and at the same time we can apply distributive property in here and distribute 2 into x plus delta x, and in the denominator 3 so will be distributed to x plus delta x, giving us now this. Then we substitute the value of y that's given equal to 2x plus 5 all over 3x minus 1. So the value of delta y now becomes 2x plus 2 delta x plus 5 all over 3x plus 3 delta x minus 1 minus 2x plus 5 all over 3x minus 1. So we have to manipulate this equation such that later, before we divide it by delta x, there must be a factor delta x at the right side. Now, if the given function involved fractions, when you solve for delta y, there will always be difference of two fractions. To simplify this, you have to combine the two fractions. So you have to find for the LCD. Review again your knowledge on adding fractions. So we solve for the, or find for the LCD. The LCD is simply the product of the denominator. So we have now the LCD is the product 3x plus 3 delta x minus 1 and 3x minus 1. To obtain the numerator, you just multiply the numerator of the first fraction to the quotient when you divide the LCD by this denominator. So we have now 2x plus 2 delta x plus 5 times the quantity 3x minus 1. This minus sign in the difference of two fractions, take note how we write it. So we have a minus, then the quantity 2x plus 5 times the quotient when you divide the LCD by 3x minus 1, which now be the quantity 3x plus 3 delta x minus 1. We simplify further this fraction. So we have to apply the distributive property of multiplication. So we now have 2x times 3x is 6x squared. 2x times negative 1 is minus 2x. 2 delta x times 3x is 6x delta x. Then we have 2 delta x times negative 1 is minus 2 delta x. We have 5 times 3x is 15x. 5 times minus 1 is negative 5. Now, in the second term, as we multiply these two factors, take note that we do not include yet the factor negative 1 in here. And so when you multiply these two factors, it must be placed inside the parentheses. So we have 2x times 3x is 6x squared. 2x times 3 delta x is 6x delta x. 2x times negative 1 is minus 2x. We have 5 times 3x is 15x. 5 times 3 delta x is 15 delta x. And 5 times negative 1 is minus 5. Okay, we are now ready to collect similar terms. Notice that this 6x squared and the minus 6x squared in here cancels out. So when we combine similar terms, 6x squared minus 6x squared becomes 0. This minus 2x will cancel out with this minus negative 2x. 6x delta x cancels out with this minus 6x delta x. The 15x cancels out with this minus 15x. Minus sign is before this grouping symbol. We have this. Then the minus 5 will cancel out with this minus negative 5. So notice what remains in the numerator will only be this minus 2 delta x and this minus 15 delta x, giving us now the value of delta y equal to minus 17 delta x all over 3x plus 3 delta x minus 1 times 3x. So notice in this equation, we now have delta x as a factor in the numerator. So we are now ready to proceed to the next step. So we now continue to the next step, which is to divide the equation by delta x. So notice, when you divide the left side by delta x, we will now have delta y over delta x. And when we divide the right side by delta x, it cancels out, the delta x cancels out with this delta x. So what remains, we now have at the right side negative 17 all over the quantity 3x plus 3 delta x minus 1 times the quantity 3x minus 1. Okay, so we now proceed to the next step, which is to evaluate the limit of the function as delta x approaches 0. So we have the limit of delta y over delta x as delta x approaches to 0 is equal to the limit of the negative 17 all over 3x plus 3 delta x minus 1 times the quantity 3x minus 1 as delta x approaches to 0. So again in here, we say that whatever we do in the left, so we have this, evaluate the limit as delta x approaches to 0. We do the same at the right side of the equation. We also evaluate the limit of the right side as delta x approaches 0. Then applying now the theorems on limit, the limit of the function as delta x approaches to 0 is obtained by substituting delta x equals 0. So that will give us now negative 17 all over 3x plus 0 minus 1 times 3x minus 1. And in symbol, again, the limit of delta y over delta x as delta x approaches to 0 is denoted by the derivative of y with respect to x. In simplifying the right side, that will now be equal to negative 17 all over the square of 3x minus 1. So this equation now shows the derivative of this function y equal to 2x plus 5 all over 3x minus 1. Let us now discuss another example to find the derivative of the function y is equal to 2x minus 5. So we start our solution by again substituting x by x plus delta x and y by y plus delta y. We have now y plus delta y is equal to the square root of 2 times x plus delta x minus 5. The second step is to solve for delta y. So we transpose y to the right side and substitute its value by the given function y is equal to square root of 2x minus 5. So when we solve for delta y, we always arrive in here the difference of two radicals. That is, we're given in here a radical function. So to manipulate, we do in here the rationalization. So rationalizing this difference of two radicals, we just multiply and divide this one by the sum of these two same terms. So we have now times the square root of 2x plus 2 delta x minus 5 plus the square root of 2x minus 5 and the same quantity with the right side. It's just like multiplying this by 1. So we do not alter the original value of the given function. So we choose in here applying the sum of these two terms so that we will be able to apply the special product or the product of the difference and sum of two numbers. So applying this formula, we now have the first term is the square root of 2x plus 2 delta x minus 5. Notice it's the same quantity in the second factor. So applying now the square of the first number, so this will give us the square of the square root of 2x plus 2 delta x minus 5. Then we have here minus the square of the second number. The second number is square root of 2x minus 5. So we have minus the square of the square root of 2x minus 5. Okay, then applying further rules on exponents, the square of square root, the square and square root cancels out. And so we have 2x plus 2 delta x minus 5 minus, again, the square root and square cancels out. So we have minus the quantity 2x minus 5. So here we are now ready to collect similar terms. Notice that this 2x and the minus 2x cancels out. The minus 5 and the minus negative 5 cancels out. So what remains in here is delta y is equal to 2 delta x all over the square root of 2x plus 2 delta x minus 5 plus the square root of 2x minus 5. Having now this delta x is a factor at the right side, we are now ready to proceed to the next step. We now continue our solution by dividing the equation by delta x. That gives us now delta y over delta x is equal to, when we divide the right side by delta x, it cancels out with this. So we have 2 all over the square root of 2x plus 2 delta x minus 5 plus the square root of 2x minus 5. Then proceed to the next step, which is to evaluate the function as delta x approaches to 0. So we have the limit of delta y over delta x. As delta x approaches to 0, we evaluate also the right side of the equation as delta x approaches to 0. So further, we evaluate or we find the limit of the right side by substituting delta x equal to 0. So that will give us now 2 all over the square root of 2x plus 0 minus 5 plus square root of 2x minus 5. Simplifying further, we now have the limit of delta y over delta x as delta x approaches to 0 is equal to 2 all over 2 square root of 2x minus 5. And this limit of delta y over delta x as delta x approaches to 0 actually is equal to the derivative of y with respect to x. And that is now equal to 1 all over the square root of 2x minus 5. This equation now represents the derivative of the given function y is equal to 2x minus 5. That ends my discussion on the geometric definitions of the derivatives and finding the derivative of some functions using the delta method. I hope you learned something. Thank you for watching.